Okay, in our previous video, we saw this x derivative and y derivative. And I want to mention a particular problem here in this particular code that you might have figured out or not. Let me mention that in this particular way, that our image x dot dtype is unsigned integer 8, which means it will never store a negative value because it is unsigned integer 8. And the reason here is actually this image s has unsigned integer 8 data type, and that is reflected here in ix and iy. So whatever ix and iy you are seeing, these are just the positive values. The negative values, they are truncated to 0. And it is always great to always make this habit to whenever you are working with images, always and you have to perform certain processing, it is always safe to first convert the data type to a floating point number or some data type that can handle negative values and so on, because in the process the image will go through a lot of transformations, intensity transformations that require a lot of floating point numbers or the numbers that have negative values to be stored inside the matrix and can be treated as a matrix or an image. So it's always good to typecast the image as np.float. Let's take a 64-bit float and convert our image in that. So after doing this, we'll convert our ix and iy to the required target data type, and it will start storing the negative numbers and more detail in floating point numbers and stuff. Let me show you the data type now. ix.d type, it's float 64, and now it will be actually handling the negative numbers as well. And if you display this again, you will get a different kind of look, because earlier the negative numbers were not playing their role. Although it pretty much reflects what we saw earlier, but maybe in a different image, it becomes a huge disaster by not changing this data type to something that is that can capture more detail. And if now you compute the gradient vector at this particular location, it is again 0, 0, but that is just a coincidence, because I was thinking that this 0, 0 is due to this unsigned integer 8. But it may be different for example, maybe it's different for a different index. Let me just check that. That's again 0, 0, because that might be a smoother region here. Maybe we move towards, let's say, 150 and 130 and may get something different, maybe. Yeah. So that was a bug in our previous implementation, and I also wanted to basically inform you, or because this is sometimes very difficult to trace that what is happening. A lot of built-in functions, they actually care about the data types and they respect the underlying data types and stuff like that. And a beginner, when starts coding, do not know what is happening. So whenever you are applying a floating point or negative kind of operations on an image, it is always safe to convert your image to a data type that can handle those kind of things. And for display, this imshow function and several other functions, they actually are capable of handling a lot of data types. You need not to worry for display, or you need not to convert explicitly to unsigned integer 8. So with that, let's meet you next time.